Guess what? Functional group time! Da-da-da-da-da-da-da-da! All right, so we need to talk about the next functional group. And we left off with this nitro functional group of NO2. And the NO2 had two peaks, one at 1600 and one at 1400. And previously I said that after the nitro group, we're going to talk about another functional group that's very similar. But this is really part of the carbonyl family. And we didn't talk about it when we talked about carbonyls for a specific reason. And that's because like nitro, it shows two peaks just like this one. So we need to figure out where these are, what type of functional group am I talking about, and everything else. So the name of the functional group is called anhydride. Anhydride, anhydride. Now, in a normal organic chemistry class, you will talk about the purpose of an anhydride and why is it termed anhydride, right? So the anhydride in general chemistry, you would maybe recognize it without water. And that's not necessarily the case in organic chemistry, but it's kind of related to that in a very small way. Okay? So what is the anhydride functional group? Okay, so the anhydride functional group is going to be a carbon that's double bonded to an oxygen. That is a carbonyl, right? However, there's not one carbonyl, but something crazy happened there, didn't it? But there's two carbonyls in total. And those carbonyls are separated by one atom, and that atom is an oxygen. So this is the anhydride functional group right here. So this can be any kind of carbon chain or ring that it wants. This can be any kind of carbon chain or ring that it wants. It could also maybe be a hydrogen if that's the case. But as long as there's two carbonyls separated by an oxygen, this is what's termed as a anhydride. All right? So in the infrared spectrum, we know that a carbonyl happens at 1700, right? This is something that we have talked about over and over and over in a previous video, or a slew of them, really. So we see a sharp spike that comes down and it comes back up, and then it goes back down to the baseline, or 100% transmittance. And we said these are very strong peaks and these are very narrow peaks, but sometimes they're broad too, so we don't really define it that way, but very often they're narrow. And like the NO2 group, this has two carbonyls. NO2 had two oxygens. And what we see with an anhydride is a very similar shape to a nitro group. The difference is that these happen at a different location. So for an anhydride, we would actually see a signal on the infrared happening at 1800, and then it goes back up, give or take a little bit, and then around 1700, and then it goes back up, give or take a little bit. And they're going to be about the same intensity. Also, sometimes this will not have time to go all the way to the 100% T. So you'll actually see it take a dip at 18, come back up, and then it curves back over to 17 and dips back down again. So it's okay if it doesn't go back up to baseline, but you will definitely see the presence of two signals, one at 1800 give or take, and one at 1700 give or take a little bit. So those are the areas that we're focused on, and that is what we call an anhydride. Okay? So if I take a look at an anhydride, an actual real functional group, here we have two peaks that are showing up. And if you look at the x-axis for the wave number, there's 15, there's 16, there's 17. So a little bit above 17, we see this peak that would traditionally be a carbonyl signal. And then a little bit above 18, we see that peak about the same distance down, and that is the presence of another carbonyl that's separated by an oxygen, otherwise known as a anhydride. That is why we see two signals here, right? Now, if we just had a molecule that had a carbon with a double bond O, and then maybe another carbon, and then a carbon with a double bond O. This is not an anhydride, right? I can't really stress it enough. It seems like people always get this confused. This has to be an oxygen here to be an anhydride. And if this is a carbon, it is not a anhydride. This is just going to be a carbonyl bond, and this is going to be a carbonyl bond. And if that's the case, then your infrared spectra would look just like it should. One peak at 1700. It doesn't really matter how many carbonyls that you have. The presence of a carbonyl shows up at 1700, and it just shows up one time. The molecule could have 15 carbonyls on it. You would just see the presence of one 1700 peak, and that is it, not 15 separate ones, right? The reason that we're seeing this is not really because of the C double bond O that shows up twice. That's the common mistake that people have. This 1700 is present because of a C double bond O, right? I'll give you credit for that one. This 1800 one, though, it's kind of coming from this blend of an ester in a way. So this ester group is right beside of a carbonyl group, and that makes this thing split off and give me a different signal at 1800. Okay? That is why we're seeing that. Not because there's two carbonyls, because if any other molecule has two carbonyls, we only see one peak, and that's at 1700. This one's slightly different, again, because of this oxygen. That's the connector piece right in between them. So I would look at this infrared spectrum, and I would see a 1700 peak and an 1800 peak, and they're both side by side, and that gives me an idea that this is a anhydride. Here's another one. This is acetic anhydride. And acetic anhydride, I see a peak here at 1700, give or take, and 1800, give or take. That double dip there, that's the presence of an anhydride. Here's another one. Again, 1700 peak, give or take a little bit. 1800 peak, give or take a little bit. And that double peak there is the presence of an anhydride. And then finally, here we have another one, 1700, 1800. That's the presence of a anhydride. All right. So a lot of times some people find anhydrides very easy to pick out. Carbonyl is one of those main bonds that we look for at 17. They're already comfortable with that number, and if they see something else that's really close, like this one was, to that 1700 peak, then they will automatically pick it up. All right. Now the difference here, that is a double peak, 17 and 1800. Keep in mind, you have another double peak, and that one's the nitro group. But the nitro group happens in a different location. We're looking at 1400 and 1500, give or take. So these are a little bit further apart. These are more separated versus the anhydrides, and they happen a little bit further down the x-axis. Okay, so that's the story with anhydrides, and now you know the anhydride functional group, and you know what the signal looks like in the infrared spectrum. So in the next video, yes, we're going to be talking about another functional group yet again, and this one is going to be benzene. And I'm going to morph this one into the aromatic field as well. So we'll talk about aromatics and what an aromatic is, and we relate that to benzene. and then we'll look for certain areas on the spectrum that show us that functional group.